Hello everyone, this is Mrs. Rondo. Today we're going to be talking about triangle congruence and we are going to be learning our first three theorems. And so here's our essential question. How do we identify and use triangle congruence theorems? Our learning goals are I can determine whether triangles are congruent using angle, side, and side. Notice I said words for those letters. We'll talk more about that in a minute. I can apply the appropriate triangle congruence theorem to a pair of triangles, and I can find missing values in triangles using triangle congruence theorem. So we have three I can statements, learning targets to work through today. Here we go. So this slide we actually did in a previous set of notes. I wanted to remind you that in order to prove triangles are congruent, or any figures are congruent, we have to know that all the sides and all the angles match up. So we did this in a previous lesson. You don't need to write this down, but we showed that all the sides in one triangle match all the sides in the other, all the angles in one triangle match all the angles in the other. We continued to talk about that. We said all corresponding angles and sides are congruent. That's what it takes in order to be congruent. However, triangles, we have some shortcuts. These theorems are shortcuts. So for a triangle only, these are only for triangles, we have the first one is called ASA, which we never say ASA. We say angle, side, angle, triangle congruence. And this does come right out of your book, this definition. I wrote it into your Google Doc for your notes for you. It says if two angles and the included side. So here's what I would say. Here's an angle and an angle. So please mark that on your diagram. And the included side, that means the side that goes between the two angles. So the angles, angle A and angle B, and then the side between them is side AB. That those, if they match up with another triangle with two angles and the included side, if those are congruent pieces, then the triangles, that's enough information for us to say the triangles are congruent. So for triangle congruence, we only need three pieces of information instead of all the sides and all the angles. We need three key pieces of information. For this theorem, it's angle, side, angle. So here we go right into an example. If we look at the first triangle, they have marked for us an angle and a theorem that we don't really go into detail with, but hopefully makes sense. If we have one right angle, then we actually have two right angles. So this right angle that was given to us also tells us there's a right angle on the left side there. So we're given two right angles and we're given matchy sides, and we're also given matchy angles. And so here we see angle, side, and angle. And we see that pattern here. Let me try that one more time. So we see angle, side, angle. So there's the angle, side, angle. And we see that going in this direction on this triangle, angle, side, and angle. All right, so that's kind of the idea, what we're looking for here. Sorry, I don't want to leave all that marking on there for later. Let's try the next example. So part B, this one, we are given definitely matchy sides. We have 1 inch and 1 inch. We have a matching angle, 38 and 38, but here they give us different degrees. That doesn't automatically mean they're not congruent. What we're going to have to do is use some triangle sum theorem here and find that missing angle R. Let's see if we can figure out what that one is. So if I have 38 and 72, I add those up, I get 110, and then subtract that, subtract that from 180, and I get 70 degrees for my last angle. And so right now I have 38, 72, and 70. Based on that information, if I look over here, I had 38, which matched up. In order to use our current theorem, which is angle, side, angle, we would need angle, here's our side, and here's the angle. We would need this angle to match this one, and we can see clearly they do not match. 67 and 70 are not the same, so these are not congruent. Whereas this one, I apologize, these are congruent. Determine whether the triangles are congruent. This one would be yes by angle, side, angle. Awesome. Cool. Then let's practice it in a proof. And as we learned previously, the first thing we're going to do every single time is write down our given. So we have angle MQP is congruent to angle NPQ. And the reason is given. And sorry, I'm just fix this real quick. Uh-oh. One more time. Ugh, so frustrating. I just want it to be pretty. Awesome. All right. And then our second one is that angle MPQ is congruent to angle NQP, and that is given. All right. And then before we go on to our final statement, let's go ahead and mark our diagram. So I'm going to go over to the diagram. MQP would be this angle right here. MQP is congruent to NPQ, which is this one right here. My second given statement, MPQ, which is this one, is congruent to NQP, which is this one. All right, then the last statement we know is going to be what we're trying to prove. Triangle MQP is congruent to NPQ. We do not yet know the reason. All right, so here we go. What we've learned so far is we can say that triangles are congruent if we know angle, side, and angle. So in our picture, we have two congruent angles. We're missing the side between them, but this side, QP, is actually the same in both triangles. So we're going to use that to our advantage. Now we have to be careful because we have to match it up. Matchy, matchy, matchy. Here's what I mean. That in the first triangle, if I look at I'm looking at Q and P. In the first triangle, it's listed Q and P. But in the second triangle, it's listed P and Q. Because our triangles kind of face different directions, even though that side is the same, we're going to say QP is congruent to PQ, like that. And because the order of the letters had to switch to match our congruence statement, this we call, sorry, it's a nice background noise. This we call the symmetric property, which you may recall from previous stuff. We didn't use it a lot, but this is called the symmetric property, and it's because the order of our letters switched. Then once we have that, oopsie, I forgot the triangle in this. Then we know that the triangles are congruent, and our reason is the new theorem we learned, which is angle, side, angle. Let me just write this in again quickly. Angle, side, angle. Fantastic. On to the next one. So in a similar fashion, we also have this next theorem, which is side, angle, side. It says if we have two sides, so I'm going to say like this side and this side, and the angle included, that means the angle between them, like angle A. If we know that matches another triangle, the two sides and the included angle, then those triangles are congruent. So that is enough information. Again, looking at three pieces of information is enough to prove the triangles are congruent. All right, so we're going to determine whether the triangles are congruent and explain our reasoning. So here we go. Looking at this one, I'm looking for either angle, side, angle, or side, angle, side. Here I see matchy, matchy sides, 20 and 20, 19 and 19. But then if I look at the angle between the sides, I have 43 and 45. So with those being different, this will not work. These cannot be congruent triangles. So these are not congruent. Okay, then for part B, let's take a look at this one. I see 74 and 74, 46 and 46. Ooh, look at that, 37 and 37. The angle between the sides is the same for both triangles, so we would call this side angle side. So this is yes by side angle side. And just to clarify, that side angle side, and it kind of goes in a circle. Side angle side, like that. All right, then let's move on to, I think we have another proof to practice this. So once again, starting with my given information, AB is congruent to AD. And my second statement, angle 1 is congruent to angle 2. I apologize. There we go. Both of them are given. And then we'll go ahead and mark the diagram. AB is congruent to AD. Angle 1 is congruent to angle 2. So we are looking for the opportunity, or we're trying to prove, let's write that down. We're trying to prove triangle BAC is congruent to triangle DAC. We don't yet know the reason. So we're looking at two of our theorems. We have angle side angle or side angle side. Right now, we have a side and an angle. So either we need a way to prove this angle is congruent to this one, which, by the way, I don't know of a way to do that without just saying, oh, it looks like they are. Or we need another side. Specifically, again, if your two triangles share a side, we're going to pretty much mark that immediately. We're looking at the letters A and C to name this side of each triangle there. So I'm going to look at my congruence statement. I have AC and AC. So this time I'm going to write AC is congruent to AC. And so this time, because I didn't change the order of the letters, this would be the reflexive property. So if it just says the same, the AC is congruent to AC, if it's same, it's reflexive. If you have to change the order of the letters, that's when it becomes symmetric. There we go. And then our reason at that point would be, if we look at what we have marked on our diagram, we have side, angle, side. Side, angle, side. So that would be side, angle, side. And yes, that's all you have to write, just the SAS. And if you want to be a little bit fancier, you could say SAS, triangle congruence theorem, but just SAS is fine. Awesome. Let's look at the last one we're looking at today, and that is side, 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 triangle congruence theorem. It says basically if the three sides of one triangle, whoopsie, got a little carried away with my tick marks there. If they match up with three sides of another triangle, then that is enough. We don't actually have to know anything about the angles. If the sides of one match the sides of the other, then our triangles are congruent. So we're going to test it out. Here I see 54 and 54. I see 38 and 38. And then I see 28 and 32 are not congruent. So this one is no or not congruent. All right, and I'm going to write that congruent symbol just a little bit nicer before we go to the last one. The last one, you're going to see this happen a lot when triangles share a side. You should basically pretty much mark it right away. And that side that they share gives us side number 3. We have side, side, and then side. So this one is yes by side, side, side. And I believe that is it for our notes. And so check Google Classroom. You should have an assignment there. And have a good day.